Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thanks for joining me, and I hope that you'll like this video if you got something out of it. And please subscribe to this channel, as I'm an independent content creator and your subscription helps to grow the channel, and that helps me to bring more videos to you. And please feel free to share a link to this video or this playlist on your professional social media sites. So in an earlier video, I had introduced LXD, which allows you to create virtual machines on a Linux server. Now, there's some advanced functionality available in LXD, specifically some commands that allow you to manage resources, or CPUs and memory, or RAM, that's allocated to a particular virtual machine. So in this video, we're going to be exploring how you can allocate CPU and memory resources to your virtual machines. Let's start by talking about memory. So if you want to assign memory to your LXD virtual machines, by default, when you provision a virtual machine, it has to have some memory at least, right? So let's say that you create an Ubuntu Linux VM with the LXC command line utility. By default, unless you otherwise specify it, it's going to get exactly 1 gigabyte of memory. But let's say that later on, after you've done some provisioning of applications and services onto that virtual machine, you start to realize that you are actually running out of memory, and you decide that you need to allocate some more additional memory to this virtual machine. Well, we can actually do that with LXD, and this is one of the great things about virtualization, is that we can simply dynamically resize or either increase or decrease the amount of resources allocated to our VMs. So what we'll do is allocate a second gigabyte of memory. Each of these sticks here is indicating 1 gigabyte of memory. So let's say we want 2 gigs. So we use the LXC config command here to set a configuration option on our virtual machine. All we need to do is provide the virtual machine's name that uniquely identifies it, and then we set this option called limits.memory and set it to the amount of memory that we want to allocate. You can specify the amount of memory in gigabytes, or you can use megabytes as well, depending on how much specificity you want with the actual value. So that's really easy to do. It's really easy to allocate. However, if we try to update the amount of memory on a running virtual machine with LXD, then we're going to get this error right here that says that we can't increase the memory size beyond the boot time size. Whenever that LXD virtual machine was started up, that's the boot time configuration, and so we can't increase the amount of memory allocated to that VM unless we first stop the virtual machine, and then we can resize the amount of memory, and then we can simply restart the server, right? So it's pretty easy to do, but we do have to make sure that we stop that virtual machine first. So it's pretty straightforward. Let's talk about CPUs. Since version 5.8, which was released around November of 2022, 5.8 of LXD, that is, you can actually hot plug CPUs. So you can hot add and hot remove CPU cores from your LXD virtual machines. And so rather than having to first stop your virtual machine like you have to with increasing the amount of memory, you can actually leave your virtual machine running and avoid interruption of your services. So once again, let's say that we have an Ubuntu virtual machine running on LXD, and by default, when we create or launch a new LXD virtual machine, we'll just have a single CPU core associated to that virtual machine. So the default is 1 CPU core and 1 gigabyte of memory. But once again, let's say that we want to increase the number of CPUs because whatever applications that we're running on this virtual machine simply require a lot of CPU processing power. It could be something like GitLab that's running a lot of CI/CD jobs, doing a lot of CPU processing, or maybe some kind of load testing application that you're running that just requires a lot of CPU resources. So what we can do is use the LXC config command again, but this time rather than setting the limits.memory, we're going to set limits.cpu, and we can simply specify how many CPU cores we want to allocate to the virtual machine. Now, LXD does also support something called CPU pinning, where you can actually take physical cores on the host and actually pin certain specific cores to the virtual machine. However, if you choose to go the CPU pinning route where you're specifying specific cores that you want to allocate to a virtual machine, then you lose that ability to hot plug your CPUs, and so it's a little bit less flexible, but you do have that ability if you need micromanagement of your CPU cores. But let's say that we want to add a second CPU core, right? Well, when we add that CPU core, if we try to exceed the number of cores available on the physical host, so let's say our physical host maybe has 4 CPU cores, like mine does. If I try to add a 5th CPU core, then we're going to get this error that says that we can't allocate more CPUs than the number of physical cores that are available. And that's pretty straightforward, right? Because we can't have 5 CPU cores on the virtual machine if we only have 4 CPU cores available on the physical hardware, right? So once we add a new CPU core, right, that CPU core is going to be brought in on an offline state. And how do we know that the CPU core is in an offline state on the virtual machine? Well, we can use the lscpu command to verify that. So we just log into the guest operating system using the exec command, or if you configure SSH access to that virtual machine, you can SSH into it as well. But we can actually use a command called chcpu to change the configuration of a CPU and bring it online from the offline state. So we could use LXC exec to execute the chcpu command on the guest operating system. Then we use this enable parameter to specify which CPU core number on the guest VM that we want to bring online. And then once again, to validate that the CPU has been brought online, we can either use the lscpu command, or we could use another type of utility like htop, or my personal favorite, which is btop, to ensure that that CPU is actually functioning correctly. All right, so now that we understand how to use CPU and memory resource allocation with LXD, let's go ahead and actually put our hands on and practice these techniques that we've just learned. So for starters, we're going to take a look at the page here for LXD 5.8. This is where the hot plugging capability was added in. As you can see, one of the primary developers, Stefan, behind this LXD project, posted about CPU hot plugging support right here. And they actually include the lscpu command that you can use to check the status of the CPU cores on a particular virtual machine. Now, if you're looking at the LXD documentation, then you'll take a look at this configure instances section, and this shows you how you can use the LXC config set command to change various configuration options on your LXD virtual machines. So once again, we just specify the name of the virtual machine, and then we specify the option equals value syntax in order to specify our options. And then if you're looking for an authoritative list of options, you can either just click this link here to instance options, or you can go down to instance configuration, expand that, and then you'll see this instance options section right down here. And then if we search for one of the options like limits.cpu, you can see that we have this option right here. It does support live updating, so that's the hot plugging support we talked about. And then if we wanted to configure memory, we could just scroll down a little bit further and see that there's limits.memory. Default value is, of course, going to be 1 GB, but we can specify an alternative quantity. And then if you're wondering how to specify a quantity of memory, you can go over to units right here, and it'll show you the different units that we can use, like megabytes or million bytes or gigabytes and things like that. So it's really up to you which syntax you want to use here, but we'll just use probably megabytes or million bytes as a suffix for our quantity. All right, so let's go ahead and get SSH'd into our physical host here. So I'm going to SSH into my Wyoming node, which is a quad core system. So if I just run btop right here, we should see it's got an i5 2500K, a little bit on the older side, but it does work perfectly fine for self-hosting services and LXD virtual machines. And I've got 16 gigabytes of DDR3 memory in this system as well. And this is a bare metal system. All right, so now what we want to do is make sure that we are running a current version of LXD. So what I'm going to do is just run LXC version, and that'll show me the LXC client and the LXD server version 5.13 right here. So that is newer than 5.8, and that should have hot plugging support. But what I'm actually going to do is create a nested configuration here. So I'm going to create an LXD VM, and that VM is going to act as our physical host, even though it's a virtual LXD virtual machine. So we're going to see nested virtualization in action. And then I'm going to install LXD on that virtual machine and then create child virtual machines underneath that LXD VM. So for starters, let's just do LXC launch --VM, and I'll just call the VM LXD so that we know what it's called. And then I'm also going to set the config here. So we'll do --config limits.cpu. And for now, we'll just set that to 2 CPUs. And then we're also going to specify config limits.memory, and we'll give it, how about 2, well, let's do 3 GIB for starters here. And then we also need to specify our image. So we'll do image server and then do Ubuntu 23.04 Lunar Lobster, which is the latest release of Ubuntu Linux. All right, so once that virtual machine has started up, we can go ahead and get a shell, an interactive shell into it. So let's do LXC exec, and then we'll do LXD, that's the name of our VM, --bash, and that should give us an interactive shell. All right, now when we want to set up LXD for starters here, just like we did in our introductory video, we need to do an apt update, and then we need to also install snapd, because the snapd package manager is typically how we install LXD. And then after snapd is installed, we'll go ahead and use snap CLI to install LXD and initialize it. All right, so once snapd gets installed right here, it'll take just a second. We can go ahead and run the snap CLI command for installing LXD. So depending on your system, of course, this will be faster or slower, and my bare metal system is a little bit on the older side here for its hardware. So let's just pause the video really quick and come right back. All right, so we've got snap installed, so let's do a snap search for LXD, and we should see it pop up right here. Now, I did want to point out that in order to install a certain version of LXD, you do need to specify what's known as a snap channel during the installation of LXD. Otherwise, you might get an older version of LXD that doesn't support advanced features like CPU hot plugging. So what we want to do is do a snap info on the LXD package, and this will show us the different release channels that are available for LXD. So typically when you do a snap install, I think the default is to follow the 5.0 channel right here, but we can specify that we want to install the latest stable version, which is going to be this 5.13 channel right here. You can see that if you want to go up to 5.14, there isn't a stable release for that yet, but there is a release candidate version available, so feel free to follow that channel if you'd like to, but keep in mind that it's not quite yet stable. So in order to install the stable version, 5.13, we need to do a snap install LXD --channel equals 5.13, and that'll make sure that when we install the LXD daemon, that it's going to use the latest release version or stable version of this package. So that'll make sure that we've got the kind of latest stable release, and that makes sure that we have all the latest and greatest features, including CPU hot plugging support. So let's just give this a quick moment to install here. All right, so now we've got the stable version of LXD installed here. If you try to run LXC and it says command not found, then just go ahead and exit out of your terminal and then just re-enter an interactive shell, and that should update the path environment variable so that you can run the LXC command. So now on our new virtual physical host, our LXD host, that's a virtual machine, we're going to do LXC version, and we should have the 5.13 version installed right here, and then we can go ahead and proceed with creating our guest virtual machines. Also, I like to go ahead and install btop, so let's do a snap install on the btop package, and that just helps us to monitor the system resources on our virtual host running LXD. So feel free to install btop if you'd like to, but there are other utilities that you can use as well, like htop or so like lscpu and things like that. So once btop gets installed here, we'll go ahead and do LXD init to make sure that we've initialized our LXD daemon, and I'm just going to accept all of the defaults right here for now. So let's go ahead and just proceed through that. And then we can go ahead and launch a virtual machine. All right, so let's do LXC launch. We're going to say dash dash VM and then images, Ubuntu 2304, and I'll just call this U01, similar to what we had in the diagram earlier. So this is going to download the Ubuntu 2304 image into our new LXD virtual machine right here, extract it, and start a new VM. Now that we've got a new Ubuntu virtual machine created here, let's go ahead and take a look at the default configuration of this virtual machine. So if we run LXC with no parameters, you'll see we have this config command right down here. The config command with LXC allows you to configure the LXD daemon. So there's certain things that you can set on the daemon itself, but it also allows us to configure the virtual machine instances on this LXD host. So let's do a LXC config. And there's a show command right down here that allows us to show the existing configuration. So if we do LXC show U01, we can see, let's do a config show command. We can see the default config here, and you're going to see that there is no configuration for the limits.cpu or limits.memory because we didn't customize those when we launched the virtual machine. So let's go ahead and get a shell inside the virtual machine. So we'll do LXC exec u01 -- bash. So now we're on our virtual machine on our LXD host. Let's do a apt update apt install snap d -- yes, and then we'll do a snap install of btop as well, and that'll allow us to monitor the system resources on the guest operating system on our LXD host. And now that we've got btop on our guest operating system, we can go ahead and just run it right here. And again, if you have an error here saying command not found, just go ahead and exit out, re-execute your shell, and try to run btop again, and you should see it right here. So of course, our guest VM has by default a single CPU core right here, and it's also got a total of 1 GB of memory. So now let's go ahead and try to change the configuration of this virtual machine. So I'm going to fire up another shell here, and I'm going to SSH into my Wyoming physical host. Then we'll do an exec into our LXD host machine here. And now on the LXD host that's hosting this Ubuntu 01 virtual machine, we're going to do LXC config set on U01, and we're going to set limits.memory equal to, how about 1500 MIB. And as you can see, it says we can't increase the memory size beyond the boot time size when the VM is running. So that message is pretty clear. So all we need to do is to shut down this virtual machine. So we'll do Q to exit btop, and then we'll do shutdown now as root. And now we can monitor for the status by just doing LXC list. And once it says it's in the stopped state, we can go ahead and just hit the up arrow a couple times to rerun the command to change the memory configuration. So now if we do an LXC config show on U01, we should see that in the configuration, the amount of memory has been modified from the default value, which is 1 gig, to 1500 megabytes exactly. So now we can restart that VM by doing LXC start U01. And once that VM comes up, we can rerun the btop CLI, and we should see that it has 1500 megs instead of the default of 1 gig. So let's go ahead and get exec back into there after we give it a second to spin up the LXD VM agent, which is what's used to communicate between the LXD host and the VM guest. And now that we've got a shell back on our virtual machine, we'll go ahead and run btop here. And we should see that our amount of memory has changed to 1.35 gigabytes instead of 1 gig, which was the default. So we still have one CPU core right here. So let's go ahead and take a look at how to modify the CPU cores. But remember, because we have a newer version of LXD installed, 5.13, which is newer than 5.8, we do have the hot plugging support in our LXD host. So what we're going to do is head over here to our LXD host, and we're going to say LXC config set, and this time we're going to say limits.cpu equals 2 instead of 1. So as soon as we run that, you're going to see we don't get any results here. But if we do LXD config show on U01, we've now set limits.cpu to 2. So it's now showing up because we've modified the default configuration and applied a custom value to the CPU cores. If we come back to the session in our guest VM, though, you can see that we still only have one CPU core. So part of that is due to a bug in BTOP that doesn't seem to update the number of CPUs in real time. I think it only reads the configuration when you start it up. But if we quit BTOP and relaunch it here, you can still see that we only have one core. So now if we use lscpu, just run it with no parameters here, you can see that we have one core per socket right here. So what's going on? Well, if you scroll up a little bit further under the CPUs section, you can see that we have CPU number 0 because the cores start at 0. So we have 0, 1, 2, and 3 in a 4-core system. So CPU core number 0 is online, but CPU core number 1, which is the second CPU, is currently in an offline state. You can also confirm this with lscpu --extended, and this will show you that CPU 0 is online and CPU number 1 is offline. So how do we bring this online? Well, as we saw in the presentation section, there is a chcpu command. And if you do --help on that, you can see that we have the --enable option, and then we can specify which CPU cores we want to bring online. So what we're going to do is say chcpu --enable, and then of course we want to enable CPU number 1, which is the one that's currently in the offline state, and now that CPU has been enabled. So if we go back and run BTOP here, you can see that we've now got 2 CPU cores online in this host. However, we didn't have to shut down and restart the host because we were able to use hot plugging support in LXD to bring this additional CPU core online. So now what would happen if we tried to downsize the number of CPU cores? Right now we have 2, but let's say we wanted to bring it from 2 down to 1. So back on the interactive shell on our LXD host, we're going to change the CPU limits from 2 down to 1. And you can see that we don't get any errors here. But if we come back to this node right here, the guest, you can see that there's suddenly no activity happening on CPU core number 1. And that's because according to BTOP, it looks like the CPU still exists even though it doesn't, and it's showing that there's just no activity on it. So once again, we're going to exit out of BTOP on this Ubuntu guest and say lscpu --extended. And now you can see that that CPU core has just disappeared. So CPU core 0 is still online, but CPU core number 1 has actually been completely removed from the system. So we've removed or hot plugged that CPU and removed it from the system, again, without having to shut it down. So in any case, that's how you can use the LXC CLI tool to configure both memory as well as CPUs on your virtual machines that you're running on your LXD host. Thanks for watching, and please like this video, subscribe, share it with all of your friends and professional contacts, help this channel to grow, and we'll see you in the next video. Take care.